Functional dependency is used in normalization. Normalization in database is used to reduce the redundancy of data. Redundancy is nothing but repetition of the same data, storing the same data in multiple locations. Okay, so we have to find out the redundancy. If you find out the redundancy, then you can eliminate the redundancy. For that, you have to find out the redundancy. We use functional dependency. So first we should know what is this functional dependency. So functional dependency it is a relationship between two attributes. There's nothing but one attribute is identified or determined by using another attribute. Generally, the attribute which is used for the identification purpose is a primary key. So most of the times in the functional dependency, we see primary key. There is a functional dependency between primary key and non-key attribute. Okay, functional dependency will be depicted like this: x arrow y. So x is called, the left side one is called determinant, and the right side one is called dependent. So y is dependent on the x determinant. Okay, so most of the times x will be a key attribute. Most of the, generally we have to create a relation like that. We have to maintain a functional dependency between primary key and all the other attributes. Okay, then now when you look at one small example, suppose there is a table with name employee and employee ID, employee name, employee address are its attributes. Now employee ID can be used to identify any row or record uniquely. So it is used to identify uniquely. So we can tell like this: employee name can be uniquely identified by using employee ID. So there is a functional dependency between employee ID and employee name. Determinant is employee ID, dependent is employee name. Employee name is depending upon or identified or uniquely identified by using employee ID. Okay, so employee ID determines employee. Employee ID determines employee name. Okay, so we can read like this: employee name is functionally dependent on employee. Employee name is dependent on employee ID. Okay, of course, there are two different types of functional dependencies. One is trivial, and another one is non-trivial. Non-trivial. Okay, when you look at the first one, trivial functional dependency. Now, the dependent, if the dependent is a subset of determinant, then it is a trivial functional dependency. For suppose A determines B. Okay, if B is subset of A, then it is a trivial functional dependency. Okay, so for example, A to A, B to B, okay, are also trivial functional dependencies. For example, when you look at, suppose there are two columns in one table: employee ID and employee name. Employee ID, employee name is one set that it determines employee ID. For suppose, okay, now this is trivial because employee ID is subset of this particular set. Okay, subset. And of course, employee ID to employee ID, employee name to employee name are also trivial. Then non-trivial. So if the dependent is not subset of determinant, then it is a non-trivial. Suppose if there is a functional dependency between A to B, if A determines B, if B is not subset of A, then the functional dependency from A to B is non-trivial. Of course, when you go for intersection of those two sets, consider A is set of some attributes, B is set of another attributes. If you perform A intersection B of those two attributes sets of those two sets, then the intersection should become null. Then only it is a non-trivial or a complete non-trivial. Examples: ID determines name, name determines date of birth. Some examples. And then inference rules. Inference rules are based upon Armstrong's axioms. Okay. Now, what is the use of this? These are used to find out the functional dependencies on a relational database. Not only see we came to know what is a functional dependency. Now we need to identify where the functional dependencies are existing. In order to find out those things, we have to use these inference rules, which are based upon Armstrong's axioms. Okay, so the third point here is it can apply to set of functional dependencies to derive other functional dependencies. Okay, so that is what the point. By using these inference rules, we can derive additional functional dependencies from the initial set. We have some set of functional dependencies we identified, but not only those, some other functional dependencies are also present. Those can be identified. Those can be derived by using these inference rules. Of course, there are six types of inference rules. Let us look into those six types. Now, the first one is a reflexive rule. So it is referred as IR1. Okay, when it is reflexive rule, if the dependent is a subset of the determinant, then it is a reflexive rule. So if there is a functional dependency from okay, for suppose if y is subset of x, you can tell like this. If y is subset of x, then obviously x determines y. That's what one rule. If y is subset of x, y is some set of attributes, x is some other set of attributes. If y set is a subset of x set, then obviously x determines y. That is what reflexive rule. Reflexive rule. Okay. So x determines y because suppose x has some set of attributes, say a, b, c, d, e, where y is set of attributes a, b, c. A, b, c is part of x, subset of x, y is subset of x. So obviously x determines y. X determines y. That is what one functional dependency, and that rule is a reflexive rule. And augmentation rule. Here, this augmentation rule is also called as partial dependency. Partial dependency. Okay, what is that? If x determines y, then xz determines yz. There is no augmentation. That's nothing but there is one more set of attributes. If those set of attributes are added to x, if those are added to y side, x side as well as y side, then xz determines yz. That is what augmentation. Okay, if there is existing one functional dependency, for that by adding an attribute to both sides, again there will be one more functional dependency like xz to yz. For suppose if there is a table or relation R with attributes a, b, c, d, if there is a functional dependency from a to b, then there will be a functional dependency between ac to bc. That is what augmentation rule it is called. It is also referred as partial dependency. And then transitive rule. What is that? If x determines y, okay, and y determines z, then x determines z. That is what transitive rule. And then union rule. What is this union rule? If x determines y and x determines z, then x determines y and z. That's what this one. X determines y, z. Okay. And then decomposition rule. This is also referred as project rule, and this is reverse of union. Reverse of decomposition, dividing. Union, combining. Okay, in union we combined, okay, two attributes, right? Y and z. Y is from one dependency, z is from another dependency. Those two are combined. That's what union. Okay. Now the reverse of this, that means what? We will start from here onwards. If x in a decomposition rule, if x determines yz, then there will be a functional dependency between xy as well as xz. That is what decomposition rule IR5, and then finally pseudo transitive rule. So what it is, if X determines Y and YZ determines W, then X and Z determines this W. So that is what pseudo transitive. Here also transitive, but little variations are there. So they are calling it as transitive, pseudo transitive IR6. With this, we completed functional dependencies. These dependencies are used in our next concept. That is nothing but normalization. That normalization I will explain in our next